What if one night Earth's moon vanished, and in its place, another moon from our solar system hovered in the sky? This isn't science fiction. It's a real gravitational question, because the moon isn't just a pretty face in the night sky. It's the reason Earth is the world we know today. Right now, Earth has one large moon whose gravity plays a central role in stabilizing the planet's tides and climate. The moon's gravitational pull on the oceans creates the familiar pattern of 2 high tides and 2 low tides per day. The moon also exerts torque on Earth, gradually slowing our planet's rotation over time. Without the moon's influence, ocean tides would be much weaker, and ecosystems dependent on tidal cycles could collapse. But what if we swapped it out? Introducing new moons, let's imagine replacing our moon with a different natural satellite from the solar system. Scenario A, a smaller moon like Europa. Moon of Jupiter. Scenario B, a much larger moon like Ganymede, the biggest moon in the solar system. In both cases, the moon would still orbit Earth, but everything else changes. How different moons change Earth. A, tides and oceans. Tides are caused by the differential gravitational pull of a moon on Earth's oceans. With 2 moons, or with a moon of a different size and distance, the tidal bulges would not follow a single predictable rhythm. They would interfere with each other. When the gravitational pull of the moons align, tides could be much higher than today. Conversely, when they are out of sync, tidal effects could cancel out, causing unusually low tides. Coastal regions that have adapted over thousands of years could suddenly face extreme flooding, unpredictable navigation conditions, disruption of marine habitat. B, climate and seasons. The moon also helps stabilize Earth's axial tilt. Without its current influence, Earth's tilt could vary chaotically over long timescales, leading to extreme climate swings. With a larger moon, the torque on Earth's axis could be stronger, potentially increasing seasonal extremes. In other words, Earth might not have gentle seasons, but violent weather shifts where ice ages and heat waves occur more frequently. C, orbital stability. Moons orbit according to a delicate balance of gravitational forces. Replacing the moon with another body, especially a large one like Ganymede, could lead to chaotic orbital interactions. The Earth-Moon system could experience unstable orbital resonance, changing the lengths of days and months over long periods. In the worst case, the new moon's orbit might not be stable at all, eventually leading to collision or ejection. This isn't hypothetical. Simulations of multiple body systems show that gravitational resonances often lead to eventual chaos. Life under a new moon sky. So what does Earth look like after the switch? With a smaller replacement moon, night skies still bright, tides irregular, but survivable. Some ecosystems adapt. Others struggle with a larger replacement moon. Ocean tides become monstrous. Coastal civilizations may not survive Earth's rotation, and seasons could shift dramatically. Some moons might make night skies spectacular, but the long-term survival of human civilization could be at risk. So we came close to asking, is Earth's moon just beautiful, or is it essential? We might admire a sky with rings of moons, but Earth as we know it could end up unrecognizable. In the next video, we'll explore a truly devastating scenario. What would happen if all the asteroids in the solar system suddenly struck Earth? Stick around, because the answers are stranger and more dangerous than you think.